Now we're going to look at some examples where we actually want to find the angle of elevation or angle of depression. So looking at this first one, it says you are standing on level ground 800 feet from the base of the store. So I want to go ahead and just draw that. So I have my store here and standing over here, and I'm 800 feet away. There is a flag on top of the building. If the building is 50 feet high, so this is 50 feet, at what angle of elevation will you need to look in order to see the flag? So looking up. I want to know what angle I need to look up at. And so angle of elevation, again, that's from below and you're looking up at something. And so that's going to be this angle right here. And now I have this set up, and this is going to be doing exactly like what we did last week when we were using inverse trig ratios. So as always, I want to start with labeling my sides. I want to label my opposite first, so I'm finding x, this angle here. The opposite side would be my 50 feet. This is the right angle. Now I need to figure out whether 800 is my adjacent or my hypotenuse. Well, when I look at my opposite of my right angle, that's going to be this side over here. And so that means that this is my adjacent. So thinking of SOHCAHTOA, this is going to be TOA because I have my opposite and adjacent. So I'm going to have tangent of my given angle, which here is x, I don't know it, is equal to my opposite, which is 50, over my adjacent, which is 800. And now if you recall, to get rid of this tangent and move it to the other side, I need to take tangent inverse of both sides. So now I have x is equal to the inverse tangent of 50 over 800. So going over back to Desmos, to get to that inverse tangent, you're going to click on the keypad, click on functions, and it's going to be right here. And I have 50 divided by 800. And I'm going to go ahead and just round to the nearest tenth. So if I round that to the nearest tenth, that means I need to look up at a 3.6 degree angle. Okay, let's try another one. So this one says, you're in a hot air balloon flying over Raymore when you spot your house. If the balloon is 1,000 feet in the air and the distance from you to your house is 10,000 feet, what angle of depression are you looking when you see your house? Okay, so for this one, I'm in a hot air balloon. And it's 1,000 feet in the air. And I spot my house. And it says, I'm looking for the angle of depression you're looking when you see your house. So I'm up above looking down below at something. So I want to know what that angle is I'm looking down at. But again, with this, I know that this angle is really congruent to this one, so that means that this is x degrees. And the other thing I know is that the distance from you to your house is 10,000 feet. So that distance here is 10,000. So I'm going to go ahead and redraw this. So I really have x degrees here, 10,000, and 1,000. So labeling my sides, I see that my opposite side is my 1,000. 10,000 is opposite of this right angle, so that means it's my hypotenuse. So that means I want to use SO here. So I'll have sine of my angle, which I don't know, so it's just labeled as x. It's equal to my opposite, which is 1,000, over my hypotenuse, which is 10,000. I'll take the sine inverse from both sides. So I get that x is equal to the inverse sine of 1,000 over 10,000. And heading over to Desmos, I get that it is 5.7 degrees.